Yes, welcome my dear students. In the last class we are explaining this topic of DTP, and our next concept is pixels and bitmaps. Okay, so here you are observing dots. This dot is nothing but a pixel. Let us see what is a pixels and bitmap. In order for a computer system to create, manipulate and output an image, okay, so if you want to process, manipulate and create an image, whether the image is scanned, photographed by a digital camera or created from a blank canvas in a painting program like Photoshop, the image must be digitized into tiny solid color area called pixel. Now what is a pixel? The pixel is a computer system to create, manipulate and output an image. Whatever the image is scanned, photographed by a digital camera or created from a blank canvas in a painting program like Photoshop, the image must be digitized into tiny solid color areas called pixels. Okay, actually dot is a pixel. It is just a dot. Okay, the individual pixel color values records the color strength of each channel. Okay, the individual pixel color values, here you are seeing the dots, right? So as we have last class we have shown one image in your paint, right? Let us say once again MS Paint. If I expand, you are identifying. If I fill some colors, you are not identifying anything. But if we load one image, okay, now I am opening this image. Now if I expand, here you are seeing dots. So every dot is treated as an these images has been created through from these pixels. Okay, then these points are placed with different colors. Got it? These points are the point, actually it is a point. Okay, you are identifying, right? Please observe here. If I click here, it is taking as one point. Okay, these are the combination of 4 points. Here it is taking 1 point. Got it? Yes. Now you are seeing this is one square. This one square is called as a pixel. Okay, if these pixels are very close, then good resolution will get it. Got it? If I reduce this, you are identifying the point. Okay, if I enlarge that, only you are identifying that point. If I see in 100%, if I see that value in 100%, you are unable to identify. Got it? It is a 1 point. Clear? Yes. Hope you understand this concept, right? Pixels. So this is a pixel. The individual pixel color values record the color strength of each channel. So if you pour different pixel with different colors, then the strength of that each channel is based on the values of a color you are using. Okay, almost gray scale black to white pixel will have just one channel per pixel. If you are using black and white image, black and white picture, then you are using grayscale black to white. Grayscale black to white pixel will have just one channel per pixel. Okay, so it is acting as one channel per pixel, and an RGB pixel will have three. Okay, so RGB channel pixel will have three colors, and rest one channel will be acting as a gray black to white colors. So that is the combination of your pixels. When a bitmap image is to be created, the first thing that must be established is bitmap's resolution. Bit, actually you know what is a bit, zeros and ones, right? Okay, bitmap means one dot. Here bit is one dot. Okay, so when a bitmap images, by using that dots you are creating the images. Okay, so when a bitmap image is to be created, the first thing that must be established is bitmap resolution. Then we have to know the resolution. Resolution means clarity of our images. Okay, that is how many pixel or areas of individual color there will be per inch. If you are seeing the resolution, then you must be concentrate on these measurement. What is the measurement of pixel, good resolution pixel? Per inch. Okay, ppi, pixel per inch. Ppi stands for pixel per inch horizontally or per centimeter, and this will also for the same vertical. Okay, so these are the units you are using for pixel or area of individual colors. There will be per pixel per inch. So per inch how many pixel has been fitted. So if more number of pixel is fitted within a per inch, then you are getting a good resolution. Okay, it may be either horizontally or vertically. Right. If an image has a resolution of 200 pixel per inch and it will be 3 inches wide. So what is a image of a resolution? If an image of a resolution of 200 ppi means 200 pixel per inch is exist, then what is the width? 3 inches wide. Okay, the images will be 3 inches wide when output at same size. There will be 600 different color blocks across each row. Then what happens? If you are using a resolution of 200 pixel per inch, that it will be 3 inches wide, and the output of the same size, there will be 600 different colors. Okay, there will be 600 different color blocks across each row. Okay, each row it consists of 200 pixel per inch. Got it? And each row consists of 600 different colors. If the image is of a 4 inch high, then there will be 800 rows. If it is a 4 inches high, then how many rows will be exist? 800 rows, and the total number of pixel or individual color areas in the image will be 4,80,000. Okay, so then what is the individual color area in the image will be 4,80,000. If the resolution is high enough, we will not see a pixelized effect when output, similar to but exaggerated in the sample above. If the resolution is high enough, we will not see a pixelized effect. Okay, if it is a good resolution means automatically your dots don't appear. Okay, that is the thing we are observing. Okay, similar to but exaggerated in the sample above. So in your home you are having TVs, right? Some of you are having latest technology TVs, or some of them are having some old model TVs. If any dish has lost its current, then you are identifying some dots on your screen. So that dot indicates it is a lesser resolution black and white screen with dots is appearing, right? That means it is a lesser resolution screen. Okay, nowadays you are getting a blue screen, right? If dish current has lost, you are getting some blue color as a background, right? So if you close observe it, you are identifying the dots in that screen. Got it? So it is also saying the same things. 8 bits equals 1 byte binary value. As we know what is a binary value, because an image is an horizontally and vertically based array of information. Then what about the image? Because an image is an horizontally and vertically based array of information, they are called bitmaps. Then what about the bitmap? Whatever the image is an horizontal and vertically based array of information, you are representing row wise and column wise, then these images are represented called as bitmaps. Okay, so then what are the types of bitmaps images are available? TIFF format, GIF format, JPG format, PIC format, BMP format, and a host of other file types are all bitmaps where the names describes the patented algorithms used to save the pixels and array information on your hard disk. So here observing we are having various kinds of images format. What are the various kinds of images format? One is a TIFF format, one is a GIF format, one is a JPG format, one is a PIC format, one is a BMP format. All these are the most of the file types are All bitmaps, all are the bitmaps only. It is representing in the form of horizontally and vertically based arrays of information, and they are all are the formation of a bitmaps. Then why these images are given the extension with TIFF, GIF, JPG, PIC means because of patented algorithms. So it consists of its own algorithms. Patented algorithms means copyrights. They have registered algorithms used for the pixel and array information on your hard disks. Okay. Yes. Next, vectorized graphics. Let us see what is a vectorized graphics. Vectorized graphics are created in drawing program like Freehand, Illustrator, CorelDRAW, etc., and even CAD programs. Okay, then vectorized graphics are created in drawing programs like Freehand, Illustrator, CorelDRAW, etc., and even CAD programs. So even in your CAD designs are nothing but by using this CAD software, we are showing your house designs. Okay, this house designs is not formed by dots; it is formed by through lines. Okay. Yes. Let me discuss about this vectorized graphics. Okay, let me see what is a vectorized graphics. We are creating this vectorized graphics drawing programs like Freehand. These are the softwares, Illustrators, CorelDRAW, etc., and even CAD programs. CAD is by using these CAD programs you can as builders are using to show the building plans, and engineers are mostly using this CAD software to show the designs. Figure shows the nodes appearing on the simple object when selected with Bezier curve editing tools. So it shows a figure here, it shows the nodes. Let us see what is a node appearing on the simple. Okay, so here you are identifying the some dots, but it is actually not as a dot, it is a node. Okay, it is a Bezier curve. With this, why it is called as a Bezier curve, we will see later. Okay, this is a Bezier curve editing tool. The curve manipulating handles are also visible on the wiggly bit at the left. So here you are seeing these dots, it is appearing visible bit at the left, right? So visible, right? The values are used to describe a virtual line between the nodes. Please observe, it is a line, not as a dot, but it is appearing in the form of a dot, but it is not actually a dot. It is not a pixel, it is a line. Okay, through these lines we are manipulating, we are processing. Okay, when I drag these lines, that is why it is called as a Bezier curve. This is a Bezier curve editing tool through these nodes, and can be manipulated with apparently simple mathematics first described by a mathematician named Bezier. So that is why it is called as curving Bezier curve editing tool. Okay. Yes, it is purely based on mathematics. Now, one scanned image of a normal happy snap photograph of the finished house using them industry standard CMYK bitmap resolution might require about 7 1.4 megabyte floppy disk. For example, if you please observe this point, one scanned image of a normally happy snap photograph, one photograph. Okay, if you scanned image of a normal happy snap photograph of finished house using them industry standards CMYK bitmap resolution, that photograph is required cyan, magneto, yellow colors. Okay, colors bitmap resolution might require about 7 1.4 megabyte floppy disk. It means 1.4 MB, 7 disks are required to store one single photograph. Please make a note. Means it required that much of a resolution. Okay, saving information for nowadays the floppy disks are not available. We are familiar with pen drives and hard disk and external disk, right? Okay, so it requires for one photograph 1.7 1.4 MB floppy disk is required. It means almost 7 1 the 7 7 4 the 28, almost 10 MB. Okay, 10 MB is required. So we are getting a 2 MB floppy disk. So that is why he has suggested as 7 floppy disk is required. Okay, saving information for hundreds of thousands of bitmap pixels requires substantially more computer resource than thousands of objects with many nodes saved in a drawing programs. So if you want to store several hundreds of thousands of bitmap pixels, then automatically it requires computer resources than thousands of objects with many nodes saved in a drawing programs. Okay, so in the programs it consists of a node. So here node represent dot to dot, right? Point to point, point to point, point to point, point to point, point to point. So this is one of a Bezier curve. It is a line. Through dragging of this line it is expanding. Okay, so that is the thing we are suggesting. In your images it consists of a Bezier curve tools, and it is showing in the form of objects with many nodes. The text object was included. Quality fonts used for DTP and pre-press are often referred to as an outline fonts. Okay, here the text object was also included. In this included, it consists of quality fonts, and whatever the quality fonts you are developed, that is a part of your pixels. Okay, yes. And prepress are often referred as outline fonts. Whatever the prepress, so by using your prepress of you are developing fonts, those fonts are referred as outline fonts. Okay, although their use and manipulation is very complex, they are computer files where the objects are described as nodes and outlines. Not unlike our drawings objects, they are not pictures of the characters. So here you are using the fonts. The fonts are based on the bitmap images, but you are having some cliparts, right? The cliparts are developed by using these vectorized graphics. So that is the main thing we are suggesting that. Okay, whatever the fonts you are using, it is referred through from pixels, but whatever the cliparts, whatever the images, right, word dots, those are the characters, they are the objects, they are described through the nodes and outlines. Okay, those are developed by using these vectorized graphics. Okay, so the meaning is like that, they are not pictures of the characters. Now printing presses. Next our concept is printing presses. Printing presses come in many shapes and sizes, from small single color presses and label printing machine to 2, 4, 5, 6 color presses and multicolor screen printing presses, up to large flexographic presses that print on plastic for wrapping, etc., and web presses several stories high printing newspapers, etc. So here the printing presses are, as we've seen, right? So most of you have visited Veda printers, right? In the Veda printers, if you observe, one of a machine is appearing there, that it is one of a shape and size. If you went for the flexi printing, there you are identifying some printing presses with a flexographic process, right? Flexographics means banners, from small single color presses and label printing machines. Okay, it comes from the range of a small single color presses and label printing machines to 2, 4, 5, 6 color presses and multicolor screen printing presses, up to large flexographic presses that print on plastic for wrapping, etc., and web presses several stories high printing newspapers. If you see this web presses, this is consist of several stories high printing newspapers, etc. Yes, a printing press requires one unit for each color that it can print. Even if a printing press require one unit for each color. For each color, it requires one unit that it can print. Okay, a one color press needs to print on each sheet of a paper 3 times to print a 3 color job. Okay, so here one calculation has given. A one color press needs to print on each sheet of a paper 3 times to print a 3 color job. Okay, 3 times to print a 3 color job. Okay, so that is the calculation. A one color press, if you are using only a single color to print, on each sheet of a paper 3 times to print 3 color jobs. Okay, it has to print thrice if you are using 3 colors. Okay, a 4 color press could print the same job in one pass. If you are using 4 color press, then it will be print within one pass only. Okay, within one pass it will be print. So to understand this concept, if you go for a flexi printing, there you will see how that machine will print, on your banners. Okay, or else you just take a color printout of your resumes. At that time you will came to know how it will print. So these are the calculations. Okay, and next, conventional offset lithography prints from a thin metal plate that contains an image using one plate for each color. So your conventional offset lithography print means your weather printers. In the weather printers, one machine is there that is an offset lithography prints. It uses a metallic plates. Based on that metallic plates, it contains an image. In that metallic plates, it contains an image to print. Then one plate is for each color. So if you are using the multicolors, then multi-color plate we have to use. Then one plate for each color has to be supposed to be placed. Okay, these clever plates are created so that TT1G bare metal will receive and hold water, while the image will receive ink and repel water. So it means that metallic plate consists of a bare metal will receive and hold waters. That metal will hold some water, while the image will receive. Whenever the image to print on the sheet, then and it will pour the ink will pour the ink on repel water. Whatever the water is placed on the paper, it will be filled with the ink. Okay, so likewise that metal is printing. Got it? So just understand. If you are not understanding, just go through in your YouTube, just try for a lithography offset print, then you will identify. Therefore the damp metal background will not be covered in ink when the inking roller applied to ink to the image areas. So hence the damp metal background will not be covered in ink while the inking rollers apply the ink to the images area. So here the rollers will exist. That roller will roll out the papers. Okay, the rollers roll out the image areas in the means the paper which has to be print, it has to be taken off. Okay, the rotating plate on the plate cylinder passes water rollers, then inking rollers, and finally transfers the image on a rubber blanket on the blanket cylinders. Whatever the image is placed on the rollers and finally transfer the image onto the rubber blanket. It consists of one of a rubber metal plate, rubber blankets. In that rubber blankets, the image is transferred through from the metals, hence it is transferred to the blanket cylinder. Okay, so that large cylinders. The blanket then transfers the image to the paper as the paper passes between the blanket and pressure cylinders. Okay, so it is just like as a blanket. A blanket then transfers the image to a paper. Whatever the image is appearing on the blanket will be transferred to the paper and passes to the blanket and a pressure cylinder. Okay, so when the smooth blanket is exist on that cylinder, and whatever the metal is placed, through that metal we have poured some ink and some water. When the water is sprinkled on that plate, the image will be formed. The image will be transferred to the blanket, and the blanket will be posted that image to your paper through the pressures. Okay, this two-step arrangement gives the process the name offset, in an offset between the plate and paper. So that is why this two-step arrangement gives the process as the name offset, as an offset between the plate and papers. Okay, let us see one video related to this offset printing. Let us check offset printing machine. Okay, so your offset printing machines are there, and let me take some small length. Yes, printing process 5 minutes is there. You just observe here. You just observe the process of print. You are seeing the cylinders which consist of rollers, and it exists of metallic plates. So here the image is placing in between the cylinders. See, he has poured the water, and a substituted ink will be exist. Okay. Here it is using some oil. So we dip that in a water. Please observe. Please observe. You are seeing that image paper. It is not as an image paper. It is a sheet. Okay. Whatever the image sheet is exist, that is a plastic substance. It has been placed inside the rollers with the cylindrical press, and you are identifying is filling the water. Okay. Now filling some colors. Please observe, he is pouring some colors. He is pouring some ink. After pouring the ink, what it will happens? So now the ink has been poured. Now we are seeing that ink has been poured under the cylinder press. When we print, it is giving in a poured printed color. Okay. Yes. So likewise, this offset litho printing will execute. Okay. Yes, you have seen, right? Yes, likewise, this offset printer will execute. Okay. Yes. Now we will see vector and bitmap images. Okay. The image produced in drawing programs that such as CorelDRAW, Illustrator, Freehand Designer, etc. are called vectorized graphics. As we know that these are the vectorized graphics. That is, all of the objects shown on the computer monitor are representation of points. So here the nodes, as we have seen in the last picture, it is showing us some point. It is the nodes actually. Okay, and the relationship to each other on the work area, each of which is stored in the computer as a special values and mathematical equation depicting. So whatever the point is appearing, wherever the point is appearing, then you have dragged that object. Okay, those are the vectorized graphics. The vectorized graphics images are formed based on lines, not as in a dots. Okay, it is because of a points is if you dragged, then some of a mathematical equation is depicted. It has been placed as some mathematical calculations. The relationship between each point and the next point refer to it. Okay, point to point is referring a, each point is referring a point and its next point reference to it, and the position of each point refer to a starting comma of the work area. Okay, so you started the image and you are dragging that. Okay, how all the points react to each other and are converted to an image suitable for human interaction is based largely on equation discovered by a French mathematician named Bezier. So whatever the image you are forming through from that points, that point is dragging and you are designing one human interaction images. Those human interaction images has been formed because of these mathematical calculations. It has been developed by the French mathematician named as Bezier, and so we now have the familiar name of Bezier curves. Okay, it is a Bezier curves applied to most of the objects created in these drawing packages. Okay, so in the drawing packages, the vector graphics, vector images has been created by using the points, Bezier curves. Okay, the node handle displayed on the monitor when adjusting Bezier curves are a simple interface used by the software to alter the mathematics and display the result in real time as we work. So whatever the nodes handled in the monitor, through from that what we are dragging. For example, if you are familiar with the Photoshop, you are cropping the image, right? You are extracting the image. Then how you are extracting? By selecting that point. You are using this Bezier curve. Through from Bezier curve you are selecting the point, and last you selected that, and likewise you are selecting. Okay, so that is all because of mathematical calculations. Through from that mathematical equations you are selecting, and the result in real time as we works. These programs are correctly called drawing programs. Such programs are called as drawing programs, and the extension of drawing programs allows us to apply color, etc. Okay, it allows us to apply colors as fills and outlines to the point and mathematically recorded areas. Also we can fill the colors of the selected areas and fill the recorded areas. Okay, that is your vector graphics. Let us see bitmap images. Bitmap images are formed through the pixels. Okay, bitmap pictures are stored as a vertical and horizontal array of pixels. So horizontal and vertical arrays of pictures, and the stored information represent the color of each of these pixels. Every row is formed and each row represent colors and colors of the pixels. The resolution of a bitmap picture describe how many of these pixels exist over a set distance, and the resolution, the clarity, resolution in the sense clarity of the image. The clarity of the image is depends upon how many of the pixels exist over a set distance. So if the pixels, that points, that dot is very closer, means you are getting a good resolution picture. If it is far, means you are getting somewhat distracted images. Okay, yes, usually horizontally, that is pixel per inch or pixel per centimeter. So pixel per inch or pixel per centimeter, it defines the unit for the distance between the pixels. Okay, the distance between the pixels are nothing but dots. What is the dot? Distance between a point to point. Okay, yes, an unaltered bitmap picture of 300 pixel per 1 inch enlarged by 1000% will therefore still have the same number of a pixel across the actual picture area, but each represented pixel will cover a larger area. If you are using unaltered bitmap images, you are unable to modify it. It means it consists of a 300 pixel per inch. How many pixel per inch? 300 pixel per inch. Even if you enlarge in 1000%, will therefore also have the same number of pixels. Even if you enlarge the image at 1000% of a zooming, and if consists of a 300 pixel per inch, then you are unable to alter it, and it is having the same area, same covered area with good clarity. At such an enlargement, the picture would be of a little use for reproduction unless viewed from a quite a long distance. So at such an enlargement, the picture would be a little use. We maybe use it a little for reproduction unless viewed from quite a long distance. Instead of view from a long distance, we can enable to enlargement. Okay, enlargement means zooming. Bitmap or photo retouching programs are correctly called painting programs. Nowadays we are getting your old images, right? If you consist of a black and white image, if you are familiar with Photoshop, then what you are doing? Retouching. If any scrambled images is also exist, we can make it as a correct one, right? So that is because of those images are based on these bitmap pictures. Okay, vectorized drawings can be enlarged as much as desired. A single company logo file produced in drawing programs could be used for a business card, any brochure or poster, or plotting out on a screen. Print stencils 3 meters 9 feet wide, whereas bitmap files would have to be created for every size used if a practicable. So if you are using the vectorized graphics, you can be enlarged as much as desired. If it is a vectorized graphics, your resolution won't spoil. Even if you enlarge it, it will show the same clarity. A single company logo file produced in drawing programs could be used for a business card. Whatever the logo we are developing for a company, if it is developed through our vectorized drawings, it will give the clarity. Okay, full resolution, and you can be used in your business cards, brochures, or poster, or plotting out to a screen. Print stencils 3 meters 9 feet wide, so 9 feet wide images it is suggesting, whereas bitmap files would have to be created for every size used if practicable. It means you are seeing a large holding, right? Large holdings as well as the brochures as well as the banners. Those large banners, if it is having a good resolution, means they are the vectorized drawings. That is the thing here it is suggesting. Okay, if you want to do the same work by using the bitmap, means it is somewhat difficult, because we have to look it over that the dots should be very closer. Okay, and image output and resolution. Yes, we will continue this image output and resolution in the next class.